Okay, cool. Hello again. I started a couple of minutes earlier because I don't want to sit here and just wait. Okay, so what did I... Yeah, so first of all, last time we looked into like this main function being this is where all execution starts. We looked at like setting up the project using cargo, which is like the similar thing to npm, and cargo TOML is like package JSON. The lock file is very similar to what we're used to as JavaScript developers. We got into some usage of namespaces, where this is refers to the standard library, where you can basically not alias, that's the wrong term, but you can basically use namespaces and then expose them directly. So this is what this line is doing. It's saying that, okay, bring in IO so that you can use IO directly. What we did last time was to install like the official REST extension for VS Code, and it really sucks because it doesn't have auto suggestions or anything. But then I got a tip from Evis at Code Sandbox. There's this other extension called the REST Analyzer. REST Analyzer, and this has a ton of stuff. So as you can see, it even gives us the type here, and it gives us auto-completion and like all the good stuff. Yes. So I guess the thing I learned reading through this, let's see. So what I'm most excited to talk about is the ownership stuff, and like memory management, which is also super interesting. But first of all, one thing I've always had trouble with is, well, I guess not understanding, but remembering the difference between statement and expression. And it makes a difference in REST, and it's really interesting because what you can do in REST, let's see. Okay, let's first talk about types, and it's basically the same types as you're used to with TypeScript. The only thing I want to point out is that numbers are more complex. So if you want a number, you have to choose what kind of number you want, and there are like 1, 2, 3, 4, 5 different kinds of numbers, like in terms of integers, and then you have floating numbers as well. And the interesting thing is that I think in JavaScript we just call them primitive values, or what's it called? Not primitive, but yeah, primitive, I think. So you have like string, boolean, number. I guess null is part of that. I'm not sure. But anyways, it's called scalar types, which I guess is a more programmy term, where you have like integer types, which is split into these 5 different things. So you have like 8-bit, 16-bit, 32-bit, 64-bit, and something called arch. And the difference is basically how many numbers you, or how big numbers you can express. So for example, 8-bit, you have, I'm literally looking at this and closing the book, and then I kind of forget. It's U8, yeah. And I don't know how large, like I didn't go to computer science, so I have no idea how big of a number you can express with this, but there are 2 types of each integer type. You have signed and unsigned. So if you put I there, then it's a signed integer, meaning that you can put minus in front of it. That's basically what it means. So you have positive and negative numbers. But if you do U, which means unsigned, then you can't use negative in front of it. I'm not sure why I don't get an error on this, but that's what I read at least. Like I haven't used this at all, so I might be saying something wrong, but that's the way I understood it. And then you have like U, 16, 32, 64, and then you have this arch thing. I'm not sure if it's actually expressed this way. Oh, sorry, not arch. use size. Yeah, which is kind of like, yeah, what the hell is that? Use size. Let me check. I read this several days ago, the types, so I don't quite remember all of it. And use size, yeah, I think that's like any size. I think so. The I size depend on the kind of computer. Oh yeah, that's a dynamic thing. So if you're running on a 32-bit system, it's 32-bit. And then if you're running on a 64-bit system or architecture, it's 64-bit. Yeah, sorry. That's what it is. And that's like really low-level stuff. So you can kind of take advantage of being on a 64-bit system if you have that or something. I don't know. Anyways. Yes. What is interesting though is that you express decimals with an underscore, it seems to me. Integer literal. Yeah, this is confusing stuff. Like, again, I haven't worked with these numbers because you can express them like with hex, octal, binary. This is stuff I've never done in JavaScript, so I have no idea what I would even use this for. But that's the way it is to be like a JavaScript developer. Been building apps, not like low-level stuff. And that's kind of what Rust does. It's for systems programming, really. But it's interesting in the concept of, so for example, something I really want to play around with Rust, just to kind of do this kind of programming, it's building like a game engine. So you have a game engine in WebAssembly, and then you use the main thread of the browser to actually render on a canvas. Maybe it doesn't make sense to do that, but it's a fun project, and it kind of gives some purpose to Rust, because or choosing Rust, because in a game engine, like collision detection and all that stuff needs to run insanely fast. So that's super interesting. Also, like I was in bed yesterday before I fell. Well, I spent some time falling asleep. But anyways, I thought about like using Rust with this virtual canvas. So you have a virtual canvas representing a resolution. It's like a 2-dimensional array, and then so you kind of, for example, you would use the correct bit size, like integer type, based on how many colors you have. So for example, if you have like 8-bit, I don't know what kind of number how many numbers you can represent with that. Is it, I don't know. So let's say 8-bit is like 8 colors or something. Then it means that your game can only be 8 colors, but the 2-dimensional array is more effective because each point in that array would be like a specific color. And then the idea is, like, I have no idea if this actually makes sense, but the point is that the main thread will only, for each request animation frame, it will ask WebAssembly and the Rust program for the next frame. And then it sends that message, and then it draws up the pixels on the screen. And then while the main thread is doing that, the Rust program will go in, tick or calculate how many ticks should it run in the game based on how much time has gone since the last message you received, which would typically be 1 tick, I guess. And then it will actually figure out what parts of this 2-dimensional array has actually changed. Because if you have pixely games, a lot of the pixels stays the same color. So the idea is that it sends a message back to the main thread, which are only the changed pixels. And then request animation frame callback runs again. You ask for the next frame, then you draw in the changed pixels, and then, yeah. Anyways. Oh yeah, 256 colors. Yeah, that's true. They actually wrote that in the book as well. But yeah, so you have a game with 256 colors. You can use this 8-bit unsigned thing, which, like, to me, I don't know much about low-level programming, but doing programming for a while now, I kind of, this is like an intuition I have. This might be super effective, and it would just be a really fun project to try out. Anyways, I'm going way off here. So those were the types for integers, and then you also have this interesting character type. So you can say like, if you use single quotes, this is like a single character. So this is a type in itself. This is not the same as doing this. As you can see, that's like a string. Well, this is a character. Again, I have no idea what I would use it for, but that's the way it is. Yeah. And what's interesting, and I guess I can tie this into the next part, which you don't really think that much about in JavaScript, which is the heap and the stack. Like, you are probably familiar with stack traces. And the way it's explained in the Rust book, it's about memory allocation. So with the stack in Rust, whenever we put like a character, we put like an int there, like any type that has a specific size, right? A size in memory, then that can be put on the stack, and it's kind of put on top of each other, and then you pop the stack. This is what we know from JavaScript. You call functions, and that builds up the stack, and then the functions return, and it pops off the stack. And the point is that the stack is very efficient, but then you have other things. You have things like arrays, arrays where you don't know the size of it. So in Rust, you typically give the size. How did you do this? Array. God damn it. I don't remember this. Sorry about this. You set the size of the array when you create it, which means that it's put on the stack, the way I understand it. Yeah, and we can just, basically we can do this. 1, 2, 3. Yeah. But then you can have like, you can have an array which is, you don't know the size of it, which means it's put into the heap. So it's kind of like, if you think about this in JavaScript, it's kind of like numbers, booleans, and yeah, is that the right way to compare them? No, I don't think, because like stack in JavaScript, you don't think about values, you think about function execution. So I don't think it's worth comparing it. At least it goes beyond me. But the point is that the stack is very efficient, and when you know the size of the value, you can put it on the stack. But if you don't know the size of the value, then it's put into the heap, and it's not as efficient to work with those values. That's the point. So they have like an example where you would typically use like the months of the year. That would be like an array where you know there's like 12 items in the array. Yes. Yeah, and then you have these other things. So we know like arrays and numbers, well, called integers there, but they also have tuples. So arrays are meant to be like arrays. All the items in an array has the same type. That's the point. A tuple is a list which doesn't necessarily have the same type. So we can have like an integer here and a string here. So that's basically the difference between them. And both of them can be, let's see, not type, but tup. And then array is 1, 2. So if I did a string here, I should like get an error. I should get an error. I'm not sure why I don't get an error. I guess I get it at compile time. Anyways, but I can access them the same way. So I can, God damn it. I can say tup 0, I can say array 0. So both of them are accessed just like an array, and I can even say .0, which is kind of cool. You can't do this in JavaScript. Or maybe only the tuple can do that. Yeah, probably. That's kind of nice, right? Anyways, just some, again, I haven't really used these types yet, so I can't like explain them in detail. I'm just kind of referring to what I've been reading about and trying to reason about it related to JavaScript. But what's super interesting, so these are probably going to talk much more about these types later, but what's insanely interesting is that you can do, you can think about these blocks as kind of like producing values. No, that's not a good way to say it. Let me show you an example first. So typically you would insert like a value like this. This is what we do in JavaScript as well. But then you're able to actually insert a block here. And then I can do 1, 2, 3. And that's actually returned into this variable. But if I do this, like I put a semicolon there, you see the type. This is really nice, the analyzer. It explains it really well. It says that nothing is in this variable. I don't remember what they call this, but it basically means nothing. And then if I don't have the semicolon, it's the return value. And this is true for functions as well. So whenever you that's what I meant to say. Whenever you have these blocks, the last statement, expression, the last, if the last line is an expression, that will be the return value. I think that's the right way to say it. So if I did semicolon here, and then I would rather do string, you see it becomes a string. But as soon as I hit semicolon, it's nothing, right? So this is kind of cool, because you can even do things like if true, then it returns that. So you can have these conditional set variables, which is super, super interesting. Cool. Yes. I think that's it. And then, yes, that's it. We haven't talked about matches, I think, which is also an insanely interesting concept. But what I want to talk about first is how we think about references and memory management in JavaScript. So there are basically, the way they explain it, are basically 3 different ways of dealing with memory. Either you have garbage collection, which you have in JavaScript, which basically makes it possible to like not think about it. Like we do have to deal with memory management in edge cases, and you kind of have to understand how the garbage collector works, but typically you don't. And then you have the other side of the spectrum, where you have to explicitly deal with memory management. Like in your code, you are like explicitly like saying, now put this thing into memory and now remove it from memory. And it can be very difficult to do. But then there is this third approach, which Rust uses, which makes a ton of sense to me at least. And that is, they base it on the scope of the function. So when I create this guess variable, this type has something called, I don't remember exactly what they called it, but like it's droppable. Like the type string is droppable, which means that when you reach the end of the execution, it will automatically remove it from memory based on the function scope, which makes a ton of sense. I guess there are like situations where you don't want that, but as I understand it, you can like override this stuff, and you can like create your own types, which are like droppable and stuff like that. So, but the point is that when you look at a function, whatever you define in that function is removed from memory when that function is done executing. Yes, and this is this ties into all of this, something called like referencing and borrowing. And the way we think about this in JavaScript, that was the first time I created a function in Rust, by the way. So I think we can just remove this because this is kind of confusing now. So let's create a new thing here, var equals 1, for example. So if I were to call some func here and pass this variable, the way we think about this in JavaScript is that we have something called pass by reference. And that means that whenever you pass like a number, a boolean, a string, or like, yeah, I guess those are the ones you think about, you are passing a copy of that value, right? It's not like when you inside a function, let's say int, when you change that to like +1, it doesn't change on the outside, right? There's a copy of that value. But then if you pass an array or an object, it's passed by reference. So if you had like 1, 2, and then how do we express array? Okay, I guess, is this how you express it? I32, something like that. I have no idea how to add something to an array actually. Okay, let's say we pushed it to something like that. The way we think about this in JavaScript is that we pass this array of numbers to this function, and then we change it. And then it also changes on the outside. Now, this is a little bit problematic in Rust, because you want to drop variables or drop values correctly based on execution, like the execution scope of the function. When it's done, it should drop the variable. So it needs to understand exactly when is it going to remove that value from memory. So the way this works, as far as I understand it, is that they have this concept called references and borrowing. And if we were to pass like a scalar type, so like a primitive type, these are immutable, and when you pass them to a function, you pass a copy of it. Okay? That's the way I understand it. And it's very efficient because they are on the stack, right? But if you were to pass like an array here, or even just passing like a string, if you were to pass a string, you actually give it. You actually give the string to the function, meaning that if I wanted to do something here with this variable, I wouldn't be able to do that because now it's invalid. I've given it to this sum func, and this sum func now owns this string value, which means that since it owns it, whenever this function ends, it will remove it from memory. Okay? This is super fascinating. So that means I can't really use it here anymore. But then it's possible for me to do something here. I can do this. So I can put this, what's it called in English? Yeah, whatever, this and sign. And that means that I'm now borrowing this variable to some func. So now some func is able to access that variable, and whenever it's done executing, it gives back, well, it never owned it, so it doesn't give back ownership, but it's done borrowing it, which means that this function can now use the variable again. There would be a different way to deal with this. I could say var equals, I could like shadow it, which means I could pass var in like this, and then let's call it var, and it's like a string type. And I could return it again, or I can just say this, which means, I don't know why this typing doesn't work. Oh, I have to, is it this string? Yeah. So I can give ownership to this function, and by this function returning it again, brings back the ownership to this function. So you can like manually move this ownership around. But typically that's too much effort. So what you do instead, you give it a reference. So you borrow, hello, go and do something, or use this, read this value and do something with it. But I want ownership. I have the ownership, so I'm going to continue using it after you're done looking at it. But the thing is, by only using this reference, you are basically saying you can read this value, but you can't change it. While if we were to, sorry for the naming here, but if we were to put and mut, and we also have to make this mut, by making it possible to mutate this value, we give it a reference, and we say you can, it's not only that you can read it, you can also change that value. And when you're done with it, I'm going to continue using it. So that's basically what it means. A reference means you can have a look at it, and then I'm going to continue use it. Or you can look at it and write to it, and then I'm going to continue using it. Yeah, and I find it super fascinating. The one question I have though, I wonder, how does this work with asynchronous code? That's something I'm really excited to take a look at. How does async code work in Rust? And also, do they have, I guess they don't have closures like you do in JavaScript. Because with a closure, you would be able to like define a function here, and then that function could look at an outside variable. But then you wouldn't, I don't know, or maybe, yeah, maybe the scope drops whatever it's looking at when the function itself drops. I don't know, that sounds super complicated to me. So I'm excited to read more about that. But anyway, yes, and I guess that's where I'm at right now. I'm still reading about functions. Yeah, and it's basically around this memory management thing. And that's kind of the gist of it, what I showed you now. But I think there's even more to it. Yeah, there's even a simpler example. So if you have, let's say you have let s equals 1, and then you say let u equals s. Oh, I hope I don't say the wrong thing now, but if we do this, we are actually making a copy in this case, because it's like a scalar type. It's on the stack. It's a simple immutable value, so it makes a copy of it. But if we had like string new, now it would create, yeah. So first of all, it would create a pointer to this position in memory, but it would also make s invalid. Interesting, right? So you're not only pointing to, you're not only referencing the same point in memory, you're actually moving the pointer over to a new variable. And this is again because Rust does this dropping of variables at the end of the scope. Is that if you had two variables pointing to the same point in memory, you would have like two drops, which is, but you can only drop it once, right? It only exists once in memory. But then because two variables are pointing to it, you would create two drops, which is wrong. You will get an error on that. So that is why whenever you move a reference into a new variable, you actually move it. The variable you move it from becomes like invalid, which is also super interesting. So you might get these. I don't think this is a big issue in practice. You kind of just have to know about it, and then the compiler yells at you if you're doing it wrong. But I think this is a really interesting balance where you don't have this garbage collector, which is not efficient at all compared to this approach. And then you have, it seems to be this really good balance between dealing with it manually and having this automatic nature of dropping the variables or dropping the values in memory. Yes. So that's, I think that's it for now. I'm not sure what's coming up here. Something called dangling references, and then the slice type. Oh, that's actually a data type. Slices lets you reference a I don't even know how to read this word. Contiguous sequence of elements. Oh yeah. Yeah, so you can probably read like something in between or something like that. I don't know. Anyways, I'll talk more about that. One thing I forgot to talk about is doing loops. So you have like while loop, so while true. You have something called loop. So while is with a condition, loop is just, it will loop forever until you break out of it. And then you have for something like this. For, I don't remember the syntax. Like one, something like this. It looks very much like in JavaScript. If I could only remember exactly how it was expressed. Maybe I should just find it. What's the loops before? Variables and no, the loops are actually after the types. Yeah, I don't think I can find it right now. Where the hell was the loops? Functions. Yeah, these are the function control flow. Here it is. If statements. Yeah, if it works exactly the same, you just don't have the parentheses. And then you have this, if it's like an expression, it will actually be a return value. Yeah, here we have the loops, loop-de-loops. While index, yeah, for element in, yeah, exactly. So you do like something like this, element in, and then you have 1, 2, 3. Yeah, something like this. I'm not sure why this is invalid, but there's something, something like this. We'll probably look more into this later. Try to actually code something. Typically that's how I learn. Like, I don't like to talk about things in theory. I'm doing this mostly now because I need to kind of just get the gist of Rust. And this just helps me remember better to try to re-explain it. And maybe we could even play around with the idea I had, just to have something to work on, like the virtual canvas, like having the colors there. Try to create some gaming logic, a game engine that ticks, changes it, figures out what pixels has changed and stuff like that. That would be a ton of fun. See if we can actually make that work. But yeah, I'll just dive through some more stuff here, and then I believe there's actually an example later. So maybe we could actually, maybe that's more fun to like go through the example, because then I can try to re-explain, like I can do the code. Yeah, maybe that's a better format. So I go through an example, I read a bunch of stuff, and then we'll work through an example in the stream, and then I'll talk about what's kind of behind the code. Yeah, that's probably better. Let's try that next time, okay? Anyways, thanks for following along, and yeah, we'll talk later.